You see in the picture the basic organs of the urinary system. Pretty much all retroperitoneal, all of it. Okay. Now the kidneys are the main structure we spend the most time talking about. They produce the urine. Okay. About 1 ml a minute. And then so that fluid, which is basically filtration and ultrafiltration of the blood plasma, is transported by this muscular tube called the ureter down to the urinary bladder. So I'm writing transport urine to urinary bladder. The bladder's in the pelvic cavity, as you can see in the picture, and always put urinary bladder. There are other bladders in anatomy, like the gallbladder, right? So, urinary bladder, basically a muscular bladder to temporarily store urine, until urination. On average max, something like 500 ml. Okay, you start to feel it at a couple hundred mils. The bladder feels really swollen around then. I'll talk about the reflex later. So the urinary bladder holds it, but then, well, you can't see it here, but then the urethra transports urine from the bladder to the outside world. So I'll just say transports urine to outside world. Right in the toilet, basically. And, well, this is the physiology way to put it. This is excretion when you do this, excretory function. I would say that the kidneys are the only organ that really execute excretion. What the kidneys are is basically a filter. It's a filter organ, and you're filtering your blood plasma like 70 times a day. And whatever nitrogenous waste products you want to get out of the body, that's your urine. So your urine is basically a filtration of your blood plasma. And it's sterile, because it's your own blood. And it's the only organ that can do that. You have toxins circulating in your blood, and the kidneys filter it out of your blood. The digestive tract is not excretion. When you defecate, that's not excretion, because those substances that are in the feces were never absorbed into the body. They just passed right through you, mouth to lips. Okay? Defecation is defecation. This is true excretion. Defecation is not. So here are the basic functions of this system. These are the basic organs. Okay, that first bullet point says conserves essential nutrients to the kidney. Well, the reason that word is used is, if the renal artery delivers all the blood, to the kidneys, and you filter all the blood plasma, if you don't reabsorb it back into the renal vein, you lose it to the urine. So in that way, by reabsorbing it back into the blood, you conserve it so you don't lose it to the urine. So the first term conserves by reabsorbing unwanted substances, like, you know, for example, sodium, glucose, and even a couple off the top of my head. Reabsorbing wanted substances back into the blood. So it's not lost to the urine. Since it's filtering your blood volume 70 times a day, it's a good organ to regulate water levels and electrolyte levels. And we already talked about that in this course. For example, for studying ADH and aldosterone. We talked about those in endocrine. Those are hormones secreted by the posterior pituitary and adrenal cortex. And they target the kidney. They help, both of those together will function in water reabsorption. As well as sodium reabsorption. And whenever sodium is reabsorbed, water follows. That's kind of what I taught you previously. So that way, because hormones target the kidney, it can help regulate water levels, helps maintain the blood volume. Thirdly, I have a critical role in acid-base balance. And so acid-base balance, you're thinking about the pH in the blood. Normal blood pH ought to be between a range of 7.35 to 7.45. Within there, a little bit basic. Okay, so you have a bit of a range to work with there. Now, for example, if you get too acidic, pH goes down. Maybe it's 7.25, something like that. For whatever reason, I'll discuss the causes later. The kidney can help compensate. You'll call it renal compensation. If pH is too low, you'll want to raise it. So how the kidney can help is it can excrete the hydrogen ions and it can reabsorb base. Excrete hydrogen ions, reabsorb the base, bicarb. These things are filtered and you can excrete, reabsorb to help compensate. Okay? Because, I mean, think about it. pH is too low, you want to raise it. So get rid of the acid and put more base in the blood. That will do it. Okay, so let me ask you the inverse. What if pH is too high? In alkalosis, 7.55. That's too high. So you want to lower it. So renal compensation would say, well, I don't know, let's say it's the, put this in blue. If pH is too high, what do you want to excrete? Which one of these molecules? Yeah, don't you want to do the reverse? Excrete the base and reabsorb some hydrogen ions. So I'm just going to reverse it. So. Okay, that's all I'm saying. And we'll talk about that in more detail. Endocrine function. So this organ, the kidneys, can secrete some hormones. Let's see here. For example, the kidney secretes renin. I talked about that before. Okay, you've seen it twice before in this class, and this is the third time you're seeing it. Now I'll teach you the cells of the kidney that do it, and when I get to it, the cells that secrete renin are called juxtaglomerular cells. called granular cells. Okay, so the hormone renin helps regulate blood pressure. We'll review that, and also kidney secrete EPO, erythropoietin. Remember, that targets the bone marrow to increase your crit. So that's the hormone function. I mean, the reason why the kidney does it is if you increase crit, you help maintain blood pressure. That's part of the kidney's function. And you correct hypoxia as well. Okay, so that's the endocrine function. And I already mentioned excretion, right? When you produce a mil a minute of urine, that urine has all the nitrogenous waste products that the body doesn't want. They're removed from the bloodstream. That's excretion. Here's a picture of a model of the kidney. Well, it's pretty simple. What's the yellow tubes? What do you think they represent on the model? Ureters, yeah? So what's this down there? Urinary bladder. So this system's not too hard to deal with. I think when you cut open the kidney and you see the inside, that's kind of where I need to explain a lot more. But we're going to do a kidney dissection. I believe they're from sheep, and they're fresh. I've asked for the fresh ones. They're frozen in the freezer now. They'll thaw out over the weekend. That's scheduled for Monday. And when you get it, it'll look something like this. Okay? Well, I think one thing you should appreciate is how do you get it out of the body cavity? In humans, I usually, when I go in through the front, all the digestive viscera are in the way because is this intra or retro? Retro. So I gotta like push all the viscera out of the way. And you can't see it. I mean, it's behind the body wall, and the kidneys are covered with what's called a renal fascia. Kidneys are retroperitoneal, covered by a fatty renal fascia. It really holds it in place well, and I usually look around rib 12 on the left side of the stomach below the spleen. I mean, I could look on the other side, but I don't know. Usually when I'm in my dissection, I always end up on the left side. But anyways, 12th rib on either side. That's the landmark I look for. Remember, that's your floating rib, so I just kind of feel for it. And then I just kind of look, and I just start like feeling for a big lump in the back body wall. And then once I feel it, I kind of like start just carefully tearing away the fatty renal fascia. Eventually it pops out. Okay. So I feel like, in my experience, that's the best way to locate the kidney, 12th rib. And then when you get it out, what you got to cut is the ureter and the renal artery and vein to remove it. And yeah, it's the adrenal glands right on top. Okay, we talked about that before. There's a renal capsule. So don't confuse the renal fascia with the fibrous capsule. The fibrous capsule is literally right on the organ. It's not the renal fascia. The renal fascia is fastening it to the back body wall. Fibrous capsule wraps around the organ. So I'll just put fibrous capsule, so it's a different structure than renal fascia. Now, the organ is obviously kidney shaped. The part that's curved in, called the hilum, contains those structures that you should be able to identify. artery and vein, blood goes in, blood comes out, right? And what is filtered and excreted comes out first through the widened portion coming out of the hilum is the renal pelvis. Then it narrows into the ureter. So it's the same too, just where it's wide, call it the pelvis, where it's narrow, call it the ureter. So distinguish between renal pelvis and the ureter, whether it be the right one or the left one. Like your bony pelvis, it's the widest part of your hips. And the pelvis is the widest part of this tube that carries the urine. Not much to look at there. You really have to cut it open to see what's inside there. And to kind of make sense of how this organ produces urine, if you look at it under a microscope, the structure you really need to understand is the nephron, shown here. Okay. Again, this is microscopic. You got about 1 million of these per kidney. And these are the structures that actually produce the urine. Okay, renal, nephron, those are words you see a lot. The word root, renal, nephron, they both refer to kidney. One's Greek, one's Latin, I can't remember what's what, but you see them crop up a lot, okay? So the nephron is considered the smallest functional unit of the kidney. So if you understand how this works, you understand how the kidneys work. About 1 million per kidney. So what the nephron is it's an epithelial tube, and it interacts with capillaries. Okay, and the function is, well, the functions are here in the key. Okay, remember the main function here is you're filtering blood and producing urine. So the first step is to filter that blood plasma right there. And you filter it in one location where the red arrow is, right there. There's a specialized capillary called glomerulus, and they perform the filtration function. So I'm writing filtration function performed by glomerulus. So the word root, glomer, means ball of yarn. It describes the shape of this little tuft of capillaries, like a little ball of yarn. We call it an ultrafiltration of blood plasma. Remember, whole blood is something like 5 liters. The plasma is only about half of that, 2.5 liters. So that is what is being filtered. You can't filter the blood cells, they're too big. You don't want to filter them, that'd actually kill you. the kidneys would fail. You only want them to filter the plasma part. Larger things can clog up the kidney. Now, the blood plasma is filtered 70 times a day. Pretty good. If you have a toxin in your blood, you got 70 chances per day to filter it out. Okay? And at a rate of about 125 mils per minute. So you're filtering a lot. Now you only produce 1 mil a minute urine. So most of that 125 is like, well, it doesn't end up in the urine. You reabsorb it basically. So the other functions, you produce the filtrate right there. It's going through this tube, and you have a chance to reabsorb or secrete things in the urine. We say you modify the filtrate. What makes it through the filter, the filtered plasma, you call filtrate. So when it's filtered, call it filtrate. So along the nephron, you have all these parts, right, after you filter. The location of the glomerulus is inside a capsule called the Bowman's capsule with the glomerulus inside. Consider this the first part of the nephron, the Bowman's capsule, with the glomerulus inside. Okay, that's where you have the filtration. This is unusual. The glomerulus is a capillary bed, and we put a capsule around it. You don't see that anywhere else. Okay, I haven't seen it. Capillary, cover it up. So that whatever filters out of that capillary goes into the tube, okay, into the nephron. And the first part after the Bowman's capsule, well, they just call it the proximal tubule. The full name is proximal convoluted tubule because it's very twisty and turny. So proximal convoluted tubule. And there you can see there's arrows going in and out. If something is taken out of the filtrate and put back into the blood, that's called reabsorption. Okay. Okay, so basically, substance X, whatever we're talking about, it's from filtrate to the blood. Now in this case, the name of the capillary that's around this tube is called the peritubular capillary. It's another capillary set. So one capillary is glomerulus, the other capillary is called peritubular capillary. If substance X is in the blood, and then it goes to the filtrate, that process is called secretion. From blood to filtrate, okay? And if substance X is secreted into the filtrate and it's not reabsorbed, it's excreted. If X is not reabsorbed, it's excreted, it's lost to the urine. Lost to the urine, in other words, it's excreted. So that's reabsorption secretion performed at the PCT. You perform basically those things along the way. After the PCT, which is my abbreviation for proximal convoluted tubule, you have this big loop. Books now call it the Nephron loop. This is an older figure. I still call it the loop of Henle after the PCT. Now, because it's a loop, there's two sides of it. There's like a descending part, it's a descending segment, and an ascending segment, right? It's good to keep ascending, descending in your head because there's a flow, there's a direction of the flow. It's flowing one way, right, through the tube. There's no two-way flow through a nephron. So you go first descending, then ascending, and then you end up in the distal convoluted tubule, further away from the Bowman's capsule. DCT for short, distal convoluted tubule. Okay, so you're pretty much done modifying the filtrate because you're performing secretion reabsorption along the way, as you can see from the figure. By the time you get to the DCT, there's not much left to reabsorb. Then you can finally dump into the what's called the collecting duct. This last part here, collecting duct. So distal convoluted tubule into the collecting duct. Now the collecting duct, they're collecting from many nephrons, not just one, as the picture implies. There's many that dump. It's collecting from many. Quote unquote, collects, filtrate from many nephrons. You can even modify the filtrate as it travels in the duct. You can perform secretion reabsorption. It's your last chance. Once you get to the end of it, you're done. You can't modify the filtrate anymore. You call it urine at this point. So where I'm pointing is the first place you have urine. Okay. So wherever the collecting duct ends, that's where you have urine. First place, you just can't modify it anymore. So there's kind of an analogy that kind of goes along with describing these four functions. It kind of goes like this, like there's a time of year where maybe you want to donate things, and say for example you have a box that's about this big, and this is your donation box, and you're going to put things in it to donate to Goodwill or the Salvation Army or wherever. So the box can only fit things this big. Okay, it can't fit things bigger. So you're forced to fit certain size objects that fit the size of your box. Okay. Smaller things can get through, but big things can't fit in the box. You're not going to donate it. So, in my analogy, what process am I talking about? Things that fit in the box. Filtration. Okay. Very small molecules can be filtered. Large molecules cannot. So in my analogy, like my kids' small toys can fit in there. I'll fill it up, okay? And I'm too lazy to take it, so I'll leave it in the garage for a couple of weeks. Right? I always do that. It just sits there, and time goes by, and my kids walk by. Hey, I want that. They take it out of the box. So what function is that? They take it out. Reabsorption. Okay. And as time goes on, it stays there. Did you take it in yet? And they go, no, 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 oh, I want to get rid of this. And it fits in the body, you just kind of dump it in there as it sits in the garage for 2 weeks. That would be like secretion. Okay, and you keep taking things in and out of the box for the 2 weeks before I take it. And, you know, secretion, reabsorption. And finally, I drive it to the place and I drop it off. And I can't modify it anymore, right? That's excretion. Okay, so that's kind of what you're doing. You just modify, filtrate, and finally, boom, it's gone. All right, so let's kind of like cut open the kidney. This is what you see. So you have to kind of marry these two images. There's nephron, there's a million nephron here. And how is it all organized? This is a good figure to study for the dissection on Monday. So make a note. And these are most of the things that you got to be able to find. So it's not a hard dissection because you just make one cut in this plane and boom, just plop it open. Okay? Got two hemisections. So we have these, like, you know, the plastic butter knives, because this community college, that's what we give you to cut. Plastic butter knife will do the job. You cut it open, basically you got this shape here going, this kidney shape. Like that, right? And you have these renal pyramids in lobes, represent lobes of the liver. I'll draw a few. And so the regions of the kidney, basically this whole outer region, like say from here to here, or from here to here, call number 1, that represents the renal cortex. And these pyramids that I'm drawing, like say for example this one, from there to there, call number 2, that represents the renal medulla, or I most commonly call it the medullary pyramid, because it's kind of in the shape of a pyramid. They call it different things. This figure calls it a renal pyramid. Same thing. It's a pyramid. Also called the medulla, because it's the inner part. Cortex outer, medulla inner. Medullary pyramid is what I usually call it. And because the pyramids are kind of, there's a gap in between, that's usually a space for blood vessels. That gap is called the renal column. And then there's this kind of like void, this kind of space. It's a sinus. It's a space. It's usually filled with fat and blood vessels and calyces. Well, anyways, renal side, they kind of like have this here. It's just the space for all this stuff to lie in. Okay, so those are the basic areas. What I wanted to do was, I wanted to draw a nephron, how it fits in with this picture, all those parts. Say, for example, you got a little, all the glomeruli, they're in the cortex. They're not in the medulla or the column. Glomerulus singular, I'll draw one, say, here, just draw a little red ball. Well, since it's in the cortex, well, the capsule, the Bowman's capsule will be there too. around it. The first part of the nephron after the Bowman's capsule, when you filtrate, is called the PCT. And how about orange? I'll just draw a little squiggly line after my Bowman's capsule. Right then, how about green for the loop of Henle? LOH, loop of Henle. First it descends, and it ascends. Then you get DCT. Running out of colors, how about I just use red again? DCT, and that dumps into the collecting duct. I'll use black. So the collecting duct goes all the way. There's a part of the collecting duct, CD, that's in the cortex. There's a part of it that's in the medulla. And it goes all the way to this tip. The tip of the pyramid is called the renal papilla. Column 5. Renal papilla. Oh man, you know what I should have put these two under here, because they kind of like go in there. So what I'm going to do is I'm going to put LOH and collecting duct. I'll put it under there too, because you can see they're kind of in both places, and that's really true. There's a part of the collecting duct that's cortical. There's a part that's in the medulla. You know, there are some loops of Henle that really extend all the way in to the medulla. For example, let's say you have a nephron that's closer to the border of cortex medulla. I'll draw another one. Here's my glomerulus. There's my Bowman's capsule. PCT, loop of Henle, and the ones that are close to the edge, the loop of Henle's go all the way down that medullary pyramid and all the way up. And then DCT right into the same collecting duct. You can see that there. So, you know, I got two nephron dumping in the same duct, and the one that's close to the bottom there, that has the long loop of Henle, are actually called juxtamedullary nephrons, because they're right next to the medulla. So this one's called a juxtamedullary nephron. And then the other one that's higher up, the loop of Henle doesn't extend as deep, and it's called a cortical nephron, because most of the parts are fully contained in the cortex. So let's call this one cortical nephron. So I drew two nephrons, but how many I say do you actually have? 1 million. 1 million nephron. They're all producing urine by dumping all their stuff, boom, in here. Now, when you get to the end, the tip there, this is, the number 5 is the first place you have urine. Okay? And it's just the kidney's job to carry it out. So renal papilla, first place you have urine. Well, if that's the case, at each tip of the pyramid, you need a collection system. Get it to the ureter. So, pretend like there's like a cup around here. Draw a little cup. Around each one, catching it, catch the urine. And these cups they kind of like merge together. To get the urine out of there. Okay? Well, let's see here. Put a little star there. Okay, the cup that's right close to the renal papilla, it's called a minor calyx. Which means cup. I wish they would just call it cup. They call it calyx because they have to be fancy. And the minor calyces, well, merge together. So let's say these two merge, or these two merge. I'll put like a little asterisk there. That would be like what you call a major calyx. So that's CALYX. This book spells it CALIX. And I usually don't see that spelling, but go ahead and use it if you want. I gave you the one I more commonly see. Now the major calyces, they merge forming what's called the renal pelvis, and then that narrows into the ureter. So let's say I have, put a double star here. Renal, pelvis, then it's going to narrow where it narrows further down, just call it ureter. That's going to go down to the bladder. Well, anyways, that's that picture. Any questions? What the dissection will be is, you'll have your kidney or dissection tray. I'll give you some pins, and I'll even give you some labels. And you can just write the name of the structure on your little label and stick the pin in it. And when I come around, it's all labeled, and it should be really quick for me to check off. This is Monday. Okay. Here's a model we have in the room next to the picture. They're very comparable. One thing I didn't go over yet, I got to cover, is the blood supply. And so here's kind of the arterial blood supply of a kidney. They kind of weigh this top part here, so you kind of see how the blood vessels distribute within the kidney. Okay, so let me kind of like draw this again, but I don't want to like just add to it. There's too much. So I'll just kind of draw it again, but I'll clear the board first. Okay, well, the main artery delivering blood, it's a direct branch off the abdominal aorta, is renal artery. So renal artery, just taking blood to each kidney. Could be the right one or the left one. This is the left one. And well, the first branch coming off, it's gonna go to in between the medullary pyramid snakes. It's gonna go to a segment of the kidney. So just call it a segmental artery. Call number 1 here. Now the figure distinguishes between, for example, anterior inferior segmental, anterior superior segmental. You don't have to do that. Just call it all segmental. The first branch coming off, and they're going to go to a segment of the kidney. Now, let's see here. When it goes in the renal column, right there, maybe this one branches, one goes that way, and one goes up this way. Okay, when it's in the renal column, between the lobes, call it interlobar. So right around here. Number 2. Interlobar artery. When it's in the renal column, call it that. It's going to branch again in the renal column. And one branch is going to go arc over that border between cortex and medulla. And the other one, another branch goes and arcs over this one here. Okay, so when it goes over the top there, call it arcuate artery. Number 3. Or here. So the arcuate arteries are at the border between cortex and medulla. They're going to send little tendrils out that radiate into the cortex, like this. Or on this one here. All those little things radiating out, number 4, are called interlobar arteries. I'm sorry, interlobular arteries. Interlobular, not to be confused with interlobar like I just did. So interlobar, interlobular. And to prevent confusion, there's another term that's more commonly used. Because these arteries radiate into the cortex, they're also called cortical radiate arteries. Cortical radiate arteries. So segmental, interlobar, arcuate, interlobular. So we have to get to glomerulus. So there's a little arteriole that branches off the interlobular. So I'll draw like little branches coming off. And the little branches are called afferent arterioles. And they deliver the blood directly to that first capillary bed, the glomerulus. So you can draw like a little ball on each of these. Call number 6. Glomerulus. And it gets too much to draw at this point, but the glomerulus is the filtration function capillary bed. The funny thing is that it's not connected to a vein. It's connected to another arterial, and I'll just list it here. It's called efferent arterial. So you have this special arrangement where normally in blood flow we see arterial capillary vein. Here we see arterial capillary arterial. And that arterial will actually go to another capillary bed. It's either going to be peritubular capillary or capillaries called vasa recta. Let me get those terms here. So this will either go, number 8, to peritubular capillary. Or, depending, vasa recta. Vasa recta means straight vessel. It's considered a capillary bed. So it's like, backing up to number 5, arterial, capillary, arterial to another capillary. Okay? And then finally you'll get veins. And the veins have all the same names as the arteries, so I won't list them here. I'm out of room on the board anyways. But any questions on the arterial blood supply so far?
Number 8.
Yes.
You said it's peritubular capillary or vasa recta.
Yeah.
Is that
Depends.
Is still a capillary?
Yes, both of those are capillaries. So let's keep track of the capillaries. There's like a lot of them, there's 3. Glomerulus is a capillary. That performs the function of filtration. These two, peritubular capillary or vasa recta, which are capillaries, they perform the function of secretion reabsorption. Okay. They be all capillaries. Is it blank where you can study? So I kind of zoomed in to kind of see in better detail. What is this one arcing over the edge of cortex medulla? Arcuate. What are the little branch coming up there? Interlobular or cortical radiate. So what are the little branches of this tree? Afferent, afferent with an A, afferent arterial. They don't show glomerulus. This figure does. What did they label glomerulus on this picture? G. Looks like a ball of yarn, doesn't it? That's what glomerulus means. So what's I? They say I. What is I? Which artery? Interlobular. Yeah. So what is A? Going to the little ball there. Afferent arterial. What's PT? All this stuff. Peritubular capillary. Okay, so in this case, it's peritubular capillary. So that's a nice picture. And here's a model. What I like about the model is they separate the blood supply from the nephron part so you can study it independently, but they're together. Okay, they're together. For example, if you did the blood supply, you have arcuate artery and vein. That's my landmark. If I see that, down here is a cortex or medulla. Medulla. Above here is cortex, where you got all this stuff. So if that's arcuate artery, that would be interlobular. Therefore, you should be able to identify that. Afferent arterial. Little berries there. Glomerulus. Okay. This little net there, PT, peritubular capillary. So what are these straight vessels down there? They're capillaries. Vasa recta, straight vessel. Recta means straight. Okay? Erect, straight, right? Recta means straight. The nephron parts. Here's the glomerulus. It's covered with what capsule? Bowman's capsule. And there's one, and there's one, and there's one. First part coming off, proximal convoluted tubule. Nephron loop going down, going up. DCT. Notice how the DCT always goes by Bowman's capsule. Remember that. It always happens. DCT goes by Bowman's capsule. You dump into the white structure, which is what? Collecting duct all the way down. Okay? So here's our general structure. There's renal pelvis. There's minor calyx. There's renal pyramid. What do we call the region from here to here? Renal cortex. What about the gap in here? Renal column. It's a space for blood vessels. Well, you should be able to identify this one. Interlobar artery. When it branches and arcs over, we call it artery. So if I had to identify this blood vessel, that would be your cortical radius. Okay. What do you call the tip of the pyramid? Renal papilla. Now, this is punctured with a lot of holes of collecting duct. So it's like a shower nozzle, like shown here. Here's a renal papilla, you're looking at it at the end of it. It's like a shower of urine, right? That's the first place you have urine. The renal papilla, renal papilla. Here's a close-up picture of our model. I know it's a little blurry. So here's my landmark. If that's my arcuate artery, what's below it? Cortex or medulla? Medulla. Now, do you see the little reddish lines in there? These straight vessels, those are the vasa recta. Okay? I know it's blurry, but let's go with it. If this is my arcuate artery, there's a branch, interlobular. Okay, so you didn't even see it blurred out. It's kind of like the corpuscle there, the Bowman's capsule there. And there's capillaries here. If there's capillaries up here, you know it's not the vasa recta. What are you going to call this capillaries? The PT. Yeah, very good. The nephron parts are shown here. Goes like that. Proximal convoluted tubule, the loop of Henle, the DCT, into the collecting duct. The collecting duct is bright orange there on that model. You can study that. So the blood flow I talked about it all the way from renal artery up to your arterial, capillary, arterial arrangement to another capillary bed, either going to be peritubular or vasa recta. So you go from red to purple to blue. And what does that always symbolize in this class? The gas exchange of oxygen. Oxygen rich, oxygen poor. So these capillary beds, peritubular, vasa recta, perform gas exchange. So what you should know is that there is no gas exchange at the glomerulus. Repeat that before. Pretty sure that's on the test. I take that back. It's on the test. There's no gas exchange at glomerulus. It performs the function of filtration, but there's no gas exchange. So I want to pack the nephron a little more, go part by part. I did talk about the two types, right? Cortical juxtamedullary, that is a, I drew that picture previously. The cortical ones, I would say the main difference is the cortical ones, they're higher up. They're just kind of like, their afferent arterial has a higher floor, so to speak, so they're higher. So most of their parts are in the cortex, hence cortical nephron. But the ones that branch off first, they're closer to the edge. They're lower down. Their loop of Henle's extend deep. And their vasa recta, what we'll learn is these long loop of Henle's, they help concentrate urine. Write that down. So LOH, loop of Henle of juxtamedullary nephrons. Help to concentrate the urine. mechanism for that, I'll cover it later. I'll just mention it now. Because that medullary pyramid is very salty. There's a salt gradient within the medullary pyramid. Because you have a salt gradient, when you force the plasma through it, the filtered plasma, the filtrate is very dilute. So when you force a dilute fluid through a salt gradient, you're able to pull water and salt out of there. And that'll help concentrate the urine because you'll have less urine volume. Okay? So when you concentrate urine, basically get this straight in your head, you're going to have less urine volume. You're going to have increased urine concentration. It'll be a deeper yellow color. Increase urine concentration when you concentrate the urine. That's what you wouldn't do. Dilute urine, you would have more urine output and it'd look more like water. So I point out in this slide the 3 capillary beds. I put those check marks by. Glomerulus, which perform the filtration function. Is there gas exchange there? No, so that's why it's red. But notice where it changes from red to purple. In the peritubular capillaries, any of these, right, they're all around the tubes. Or this one here, vasorectal, it's purple, right? So you go from red to purple, and then it goes from purple to blue when you get back to the veins. Okay? This is a good spot for a break. Let's take a break and we'll pick it up from here.